Hey guys, Blue Kool-Aid coming at you. I'm going to give you a video. Hey, we had another CME. It's coming from this Sunspot 2741. There's been a couple interesting things with this. Again, this is the view from SDO, which is our view from the Earth. So keep that in mind when we're talking about this. This first one, 2740, fizzled out. And this one has actually gotten really, really weak also. I won't say really weak, but it isn't as strong as what it was. And it's coming around Earth facing directly. Okay, Earth facing directly would be probably about right here. All right. Now, why is that important? Well, because it is starting to fizzle out. And it falls right in line with Scott's theory of a 28-day orbit. And it doesn't necessarily mean that there can't be action outside of that object. It just is increasing the odds, okay? We have to really, pay attention to that. But when we see things and then objects get illuminated and stuff like that, you have to directly relate it to that. Plus, we're in a solar minimum, guys. I mean, they say that we're not really supposed to get deep into it or even the start of it till like the middle of June. Well, I'm here to tell you guys that it's here. It's happening now, and it's going to keep getting. The sun itself is going to keep going to sleep week after week after week. Here, you're gonna notice it. Okay, well, we're already seeing it. Like I've said before, 7 years ago there would be sunspots all over this sucker. Okay, I mean honestly, I've shown pictures of it before, and it would this capture right here would be so much brighter to begin with. I mean, you can visibly see it, guys. So as we're slipping into this quiet lull period in the sun, and into a grand solar minimum, we shouldn't be seeing we shouldn't be seeing this much activity, I guess. For lack of a better terminology there. So anyway, we did have a CME, and it is, Earth facing. Something else I want to point out here. See this down here? See that little dot? That's the size of the Earth. Okay? So if you can put that in perspective, just kind of imagine how many Earths you could fit inside just this sunspot. Okay? Let alone the whole sun. That's the difference in the size, guys. Okay, so when we're talking about sunspots, these things are huge in size compared to our Earth. Now, compared to the sun, obviously it's small, but this is the scale of things. You got to really understand that. Now, again, I just said that CME was Earth facing. I'm not saying it's a direct hit, and I'm going to explain what I'm talking about. Okay, we can catch a glancing blow. We can catch a pretty decent size hit. We can, and obviously we can catch one right on the chin too. But I think this one is actually, if you want to put direction on this, maybe getting shot out a little bit towards the southern pole. Okay, not pole of the Earth, but towards the southern pole of the sun in that direction. And I'll show you what I'm talking about. But where we're at right here, I'm over here at Suspicious Observer's YouTube channel. And he was talking about this morning, Ben was. And he puts out, daily space weather updates. He does some articles and all kinds of other things. It's one of the stations I do go look at every day for space weather. He explains what we're looking at, and I'm going to explain here also. But just listen to what he has to say here real quick.
Along with the actual X-ray production. Primary concern, best guess, would be for that central dark filament to erupt, but it would need the sunspot's help to do so. Solar wind.
Okay, now you heard that, right? He said best bet of any activity, because he was talking about these sunspots coming Earth facing and fizzling out, just like Scott was saying. Okay, and Ben said that our best bet for any action to happen would for this filament right here to release. But again, he said it would have to have the help of the sunspot to do so. Well, I'll be danged if that ain't what happened. um, I was completely taken aback by that's exactly what happened. Okay, and I'm going to show you. It's crazy how it worked out. But first thing I'm going to do here, guys, is I'm going to take you over here to seeds and let you guys see it on these views from the Lascaux C2 and from Core 2. Okay, now this is Lascaux C2. This is from the 12th. Obviously, you've seen the start of it, and what I'm going to do is I'm going to take it frame by frame once it gets up there again here. Okay, I'm going to pause it. Oop. Okay, so let's just take it back. Okay, we had another one that popped off earlier too that was directly earth facing. Okay, I think that was yesterday. We should be feeling the effects of that, I think on the, I can't remember what day, 4 or 5 days. But anyway, this is the last capture on the 12th. Okay, now you can't really tell. You could tell there was a CME over here. Okay, because look at the halo it left. So this when you see something that big, you know that it was a sizable eruption. And when I show you the picture on the SDO, you're gonna know, because it isn't a small one this time, guys. This isn't some little small flare. This is something that was pretty sizable. I don't know how big. They haven't come out and said exactly how big this thing is yet, obviously, because it's just now happening. I'm gonna back it up to the beginning here of this one, so you guys can see how it started on Lascaux C2. All right, now what I want you guys to keep in mind on this, and I've said this before, when we're looking from Lascaux C2, we're looking from the view of the Earth. Okay, it's from SOHO. So anything that's happening behind this disk, we can't see. So that's why sometimes you see these big bright flashes and you don't see anything with them, because this is not the surface of the sun. This is the occulter. Okay, and I've explained that a few times. Now I'm going to zoom in here. Okay, now you're seeing how this thing's blowing off, right? When we see these things, and I've said this before, we can't tell if it come from the back of the sun or the front. Okay, because of that occulter. We just can't see it. So we have to go look at different tools to figure it out. So let's just back that up a little bit more, because that right there was right before we seen it for the first time. Now you see this little bright area. Okay, that's the beginning of this. Okay, it has already erupted because the sun is here. The surface of the sun's right there, not out here. So just keep that in mind. So I'll go next here, and you see that how, and this one here also seems to be moving at a pretty quick pace because it shot out pretty quick, like. Okay, and again, you can see it what it's doing here. All right, so we'll go to the next day, which is the most current imaging that we can see. I'll slow that down a little bit. Okay, now you can see all the energy that's all through here. Even it didn't just stop like halfway. I mean, it went back like this. Okay, it wasn't a full halo, but that's a sizable eruption, guys. It really is. You know, and it looks to me like the filament did come off. All right. And when that happens and that plasma gets released, that's what makes it classified as a CME. Some of the mass was released out in towards whatever direction it was shooting it. Okay. So, with that being said, how do we know if that's Earth facing, right? And I've explained this before, but this is a good opportunity for me to show you guys again. All right. Now this is the Core 2. Now I'm going to go to the previous day because that's what I should have done to begin with. Okay. So I'm going to stop it right there. Now, this is the view from stereo A, and I'm going to explain to you here in a minute what that means. Again, and it's going to be very quick, okay, because I went in depth in a previous video, so I can't explain it every video. I'll just point you guys to the one that I already made. Now, you're seeing this, right? Okay, so the Earth itself would be off to the right, okay, because the satellite's over here looking at the sun. This is stereo A. All right. Now, when we're looking from SDO or SOHO, it's right here. So just keep that in mind. But what I want you guys to pay attention to, just for this particular eruption, the Earth is here. Now, you see this direction, right? See how it's kind of going southward? okay, for lack of a better terminology. It's kind of going down instead of just directly at us. Okay, that gives us, when we're looking at stereo A, we can kind of see as far as if it's going north or south or straight at us. Okay, but we can't tell if it's like, you got to really try to think of this in 3D. Okay, I know it's hard to do, it really is. So then it does that, right? Let's see here. So within, let's see here, 21:24, you look at that, and then 23:54, in 2 hours it went that far. And I just showed you how big the Earth was compared to the Sun, so that's a vast distance it's traveling. So in my opinion, this thing's moving pretty fast. Okay, now I want to show you guys something else too here. If you look real close, and it's hard to see, there's almost like an object right there. Okay, I know it's hard to see on this one because it's very pixelated. You go over here, it's kind of there too. Alright, now I just wanted to point that out because, yeah. So, and then this right here is the most current imaging. Alright, now you're seeing, again, what I want you to understand is the Earth is over here. It's not quite, if you're looking and this is our sun, we would kind of be way over here. But you can see when as this thing erupted, that it's going to keep spreading out. So even if the Earth isn't right in the middle, we could still catch a blow from this, which I think we're going to. And what I'm looking at here, it almost looks like we're going to be catching a pretty significant blow. So anyway, I will take you guys over here to the. I made a little video here. Let's so you guys can check this out. This is the view from the Earth. This is over here is from GOES 14. Okay, this is almost like an X-ray view, but it does show it pretty well. I'm just going to hit play and let it play here. We'll let you guys watch it here for a second, and I will pause and go. Okay, see how bright that got? Look. Okay, and boom, it erupted. Okay, now again, I'm gonna zoom in there. Remember what he said. He said that it would take the sunspot's help for that to happen, and that's exactly what you just seen right there. Okay, that filament he was talking about is basically right out here. And I'm going to back this up, and I want you guys to watch it for a second. But this is the sunspot. You're going to see this thing connect to this filament. Okay, and then the eruption happens. Okay, so I'm going to push play. See that? I'll walk it back again. Right there. See that? And then, boom. You see that? It gave it enough energy to go ahead and erupt. That's what happened. Okay? That's what they mean by that sunspot needed help. Well, not sunspot, but the filament needed help to release. It got enough energy and it finally released. So, anyway, I got you a couple different views here. We'll go ahead and watch this throughout here so you guys can kind of check it out. You see that? These are just other views. You can see them pretty well here. And again, these are just a bunch of different views from the SDO. Okay? Yeah, I know I was stopping and starting there. But now I'm going to pause it here and show you this one, okay? Remember the filament's right here. This is the sunspot. And again, you're going to see it just kind of connect to that filament and give it enough energy to erupt. That's what happens. Okay, hit play. Boom. Alright, does it again. Boom. You see that? I mean, that's just wow. I mean, I just think it's really cool to see. Now, if it's directly Earth facing, guys, this is, this could be a pretty good hit on us, especially with our magnetic field being weak. Alright, this is the purple view. You can see that. And again, guys, no fear, but we do have to be aware. I mean, this is something we have to pay attention to. Okay? Now, this is the view that a lot of people like because it does show it pretty clear. You see all that action right there? I mean, and you can clearly see it was that filament that he was talking about. And exactly what he said needed to happen, happened. Look at that. Okay? It just blows my mind when stuff like that happens. Somebody will say something like that and then it actually happens. But this sunspot is still not as strong as what it was. It's still petering out. Okay, I have to reiterate that. Okay, it just reacted with that filament, which had some energy, and it was enough just to go ahead and release, and it ended up being sizable. Okay, so I'm gonna take you guys over here to my and explain a couple things here real quick. Oops, let's go to my screenshots. And let's go to start here. This is the Lascaux C2. I took some still shots. Now you see this, right? All right. I mean, that's the view from it. There's the next one. Okay. And here's the core 2. This is from stereo A. Okay. Now this is that little diagram I was showing you guys. Okay. This is the one I made. It's crude and everything else, but it's okay. Here's SDO. This is how we tell if it's earth facing or not. This is stereo A. So all those pictures of the sun I just showed you were from the SDO. They were here. Okay, so we were looking right at it. Now the one I showed you from core 2 was looking from over here. Okay, but we can tell by looking at the sun through SDO if it's coming our direction, and then we can tell from stereo A if it's going to slide underneath us, on top of us, or right at us. Okay, that's the best way to explain it, I think. So that being said, you know, that's us looking at the sun right there. That's our view. And then we would be over here. This is the one that happened the other day, okay? This is the one that happened, I believe, on the 11th. Yep. Now you see how this one, the Earth would be right here, right? This is coming right at us. And on the CME tracker, Scott did a video. You guys should go check it out. He did a live stream. He explained that, okay? This thing is heading right at us. We're going to catch us right on the chin. Okay, now is it going to be something huge, big, huge event? I don't think so. Okay, guys. I don't think Scott thinks so either. But we will see some effects. You know, our space weather will get all jacked up. Magnetosphere will react. There'll be some, you know, there might be a little bit of satellite issues with them getting shut down and stuff just to protect them. We could see some cell outages. We could see some very, very minor electrical issues. I don't see no big grid going down or anything like that. But, you know, you just never know because our magnetic field is so weak. Our shields are so weak. They're getting weaker. Okay? And it's because the sun's getting weaker. All right? Sorry about that, guys. I had to shut the recording off there for a second. So you might hear a little glitch there. Anyway, I'm going to talk about UV here for a minute. I work in lawn care, and it's pretty important to me because I'm outside in the sun, okay? And I know it's important to a lot of you guys, and this has been part of the conversation in our community here for quite some time. We're seeing strange things. We started seeing stuff really strange on the UV end of it last year. I can tell you this, that I've got guys I work with that have awesome base tans, never burn, that are burning now. Okay, we're talking guys that have worked out in the sun for, 20 plus years. So with that said, keep that in mind because this isn't something that I personally take lightly because this really could get people sick. And when you got somebody that has been in the sun that long telling you, hey, this is not normal, you really need to be like paying attention and trying to see what you can figure out. I shared that story with Scott. I think Scott used it in his live stream, which is awesome because I want to bring some awareness to this a little bit. But I think I've come across some stuff that may be why we're seeing UVC now, okay, on the surface. Now, I'm going to read this to you here real quick. I just pulled this off the internet, guys. These are just articles anybody can Google and go look at. And I'll leave links and stuff, but I want you to I'll show you where I want you to pay attention to because there's some words here that are rather disturbing because stuff shouldn't be happening. It says ultraviolet radiation obviously is part of the sun's light spectrum that reaches the earth. UV radiation breaks down into wavelengths. Okay, that's how they differentiate between UVA, B, and C. Okay, guys, this is different wavelength. Now, the shorter the wavelength, the more intense the UV is. Okay, when we're talking about putting sunscreen on, we're talking about UVA and B. That's what it protects against. There's no sunscreen out there that protects against UVC. Okay, just know that. You would have to put clothes on, I think, and sometimes I don't even know if that would even matter. But just depending on what kind of stuff you were wearing. But anyway, this article says here, it says, fortunately, now listen, only UVA and UVB rays can penetrate the Earth's atmosphere. Wrong. Okay, yeah, I don't know if that's wrong or not, but I do know that we're seeing UVC on the surface, and let me explain. I think it's a little bit of both. I think our atmosphere is getting either holes in it, like we talk about ozone holes and stuff like that. It's getting weaker for some reason, or it's coming from an artificial source. Okay, such as a sun simulator, maybe. Okay, that's where I'm going with this. I want you guys to really pay attention to this because, yeah. It says applying a broad spectrum sunscreen greatly reduces their effects. It should reiterate there, UVA and UVB. It does nothing for UVC because they don't protect against it because they say the Earth's atmosphere absorbs it all. Okay, well, I'm going to show you that whether the Earth's atmosphere is absorbing it and it's not coming from our sun, if that's not the case, then it's got to be coming from something inside our atmosphere, such as a sun simulator. Okay, go on to this. Okay, same article. UVA accounts for 95% of UV radiation that reaches the Earth's surface. Okay, and it's used in tanning beds. It penetrates the second layer of the skin. You can read all that. Okay, UVB affects the top layer of the skin, causes most sunburns. Okay, that's UVB. All right, we're talking the last 5% of all the UV rays, because it says 95% of the UV radiation that reaches the Earth's surface is supposed to be UVA. Now, what I want you guys to look at here is UVC. Does not reach the Earth's surface, absorbed by the atmosphere. It's not normally considered a risk factor for skin cancer because it's not supposed to penetrate our atmosphere. All right? It says, is found in man-made sources of UVC radiation, such as mercury lamps and welding torches. Okay, you ever heard of welder's burn? Welder's burn is, some of that's caused by UVC. You're getting UVC off of that. Okay, some of the bulbs I used in my printing job that I had for over 20 years, we would get burns on our eyes if we didn't wear proper protection. We wouldn't even know it because it can be reflecting off of other stuff. Keyword, reflector. Okay. This is where I'm going with this, okay? Now, I have to keep saying this. It says it does not reach the Earth's surface, UVC. Okay? So we go on here, and it tells you the difference here again. The shorter the wavelength, the more harmful. Okay? That's what they're talking about. It's measured in nanometers, I think, is how they measure that. But it's the measurement of the length of the wave, the light wave. Okay, and it says shorter wavelengths. Da 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 da. Okay. However, it is completely look. They're even reiterating it here. However, it is completely filtered by the atmosphere and does not reach the Earth's surface. Okay, so who's lying to us now? Okay, or because they're definitely not coming out saying, "Hey, oh my gosh, UVC's is hitting the surface now." Okay, nobody's saying that. Then here's an article. Okay, is UVC safe? It's from Dr. Kevin Kahn. I don't know much about this guy, but he was his principal field application engineer. All right, Clarion University knowledge base. That's where this article came from. All right, it says UVC radiation, 28 nanometers is anything shorter than 28 nanometers is considered UVC. It says these wavelengths are entirely absorbed by our atmosphere, and listen, and no natural UVC radiation reaches the surface of the Earth. And here's why. Okay, it says These wavelengths are available to us through artificial sources such as, now listen to this, UVC, LED, or mercury lamps. Okay, UVC, LEDs, or mercury lamps. Now this technology, UVC to LED, like mercury lamps, have been around for 100 years, I think, or close to it. Okay, the intensity from point source, and this is why they say that we can't really get natural UVC. It says the intensity from the point source would be the sun, right? Like UVC LEDs falls off as 1 over distance squared. Basically what they're saying here, guys, without going to mathematical stuff, the further away the source is, the less amount of UVC you're going to be getting. How far is our sun from the Earth? 93 million miles. So, now granted, the source is very, very potent, the sun, okay? Not as potent as it used to be, but it's still potent, okay? So, we're 93 million miles away from it, so you would think that, yeah, you know, maybe they are right. Maybe any UVC that's coming off the sun can't penetrate the Earth. Well, then where do we go from there? All right, now, it goes on to talk about what UVC does to you personally. It goes down to the molecular level, guys. UVC does. It can go straight to your DNA type of situation. You know, I guess in high doses. I'm not sure what kind of dose it would take to really, you know, unless you're exposed to it over a very long period of time, and that's kind of what we're thinking here. Okay, this is something that didn't just pop up. Okay. This is something that's been happening for, I don't know, a couple years. But anyway, again, sorry guys, I had to cut the video off there for a minute. I got family and stuff walking through the house. Anyway, what can you use UV for? Is there anything positive from UV? Okay, well, yeah, there actually kind of is, and I'm going to go into this here real quick. UV sterilizer. This right here they use this to purify water. Okay, it's one of the newer technologies. Well, it's not really new. They use it in water treatment plants for a long time. But now it's becoming like personal use. Okay. Anybody recognize that? Some of the captures we've seen, like when the simulation system breaks down. Does that look familiar to anybody? It's a UVC LED series target air purification. Okay, yes, they use UVC to purify air, guys. So what does that mean? Why am I even showing you this? Why am I bringing this up? Well, if they figured out how to do this or use this, they can either use this as a weapon, okay, to target certain areas, certain countries or whatever, to make people sick, or they could be doing this for a good reason, and maybe they figured out how to purify. Maybe we've had, you know, like massive, you know, these super bugs and stuff. Maybe they can use this kind of stuff to purify air on a large scale. Now, I'm not saying that that's possible. I have no idea if that's possible or not. All I'm saying is that this is what this UVC LED series stuff is. Okay, they use it for air purification. And this circular lines in this thing, we've seen stuff that looks like this in some of the captures we've caught, guys. Okay, and even the middle there looks like some of the stuff that we see. Okay, now I just wanted to, you know, I'm just throwing that out there. I'm not saying that that's what's going on, but, you know, could it? Now, been talking a lot about UVC. Now, Mr. MBB3 does an awesome job. He has a team across, I think it's across the world even. It might just be like here in North America, but I think that he has some people overseas and stuff. He calls it Team UV. He's been doing this for years now. So what he does is, and this is what I'm talking about. What he does is that these guys have these instruments and they can see what the UV is where they're at just by turning this instrument on. The one here on the left If you look close enough, it says AB, right? That's UVA, A and B. Okay, that's the number it's giving you. Now, you know, a normal number, depending on where you're at, varies. Okay, if it gets around 10 or above, that's very high for UVA and B. In other words, it's intense. Okay, chances of getting sunburnt is a lot better, a lot bigger. Now look over here. UVC, it's showing 23. Okay, it's picking up UVC. But wait a minute. All those articles we just looked at was saying it was impossible for natural sunlight to make it through our atmosphere, UVC from natural sunlight to make it through our atmosphere. So something's, you know, bunk here, guys. All right. Now he was seeing this stuff last year. Okay, and he talked about it and went into it and, you know, said that we should not, he even says it, we should not be seeing UVC on the surface. And he's right, we should not, but we are. And this isn't just in one spot, guys. Okay, look at this. Team UV record high UVC reading. Okay, now I can't tell you exactly, you know, the scale of that. Okay, because I don't know. Even the A and B, I'm not sure what, I think, like I said, I think 10's like a really high, like extreme. So like a middle of the road number would be like a 5, I would think. But this right here is different than the AB. This is UVC. This is the stuff that should not be hitting the Earth's surface. You see this little wand here? That's the instrument picking it up. Look how close it is to the ground. So you know it's on the ground. Alright, this instrument's picking up UVC. And so was this one. Same instrument, different location. They're all over the place. Okay? And depending on what time of day, what time of year, things vary. I think Team UV even, his team here, they don't really report during the winter, I don't think a whole lot. I'm not sure on that, but I know during the summer he definitely gives daily updates on this. Okay? And I would encourage you guys to go over and check out his channel for this because he does. They keep a great eye on these UV readings. And sometimes what he'll do is he'll compare it to the National Weather Service, the UV outlook that they're trying to say is happening, and compare it to the readings that these guys are showing. And there's a lot of times that what these guys here are showing is a lot higher than what they're actually telling us it is. Okay, so why would they do that? Is it for nefarious reasons or good reasons? Is it that system up there for the sun simulation up there? This goes back to this subject. Is it for good or is it for bad? Is the good coming from it a side effect from the bad that they're trying to do with it? I don't know. All I'm telling you guys is UVC is on the surface. And in my opinion, it could very well be coming from our simulation systems. Because they've been trying to figure out why are we seeing UVC on the surface if our atmosphere is supposed to be absorbing it all. The only other answer besides artificial stuff, guys, is that our atmosphere is depleted so bad now, and it's very possible that UVC is making it through all the time. And if that's the case, they need to be telling everybody, okay, because people are going to get really, really sick and really, really fast. And this is something that's probably been happening for a while. You know, at least since they've been doing these readings and looking for UVC, which has been a couple of years now. Okay, at least 2 years that I know of that they've seen it on the surface. And again, I have to say this. It's not supposed to make it through our atmosphere, guys. None of it. Because the sun's 93 million miles away, I would say that the dose of UVC that we would get from a natural source would be fairly low, and then our atmosphere should be able to absorb that. That's kind of what they're telling us. But if it's not doing that, and it is coming from the sun, then we got a big problem with our atmosphere. And if that ain't the case, then it gives validity to it, something artificial in our skies causing some of this. Okay? So what other reasons could there be why we're seeing UVC on the surface? I can't think of any other than those two, in my mind. So, you know, and again, guys, here's the light spectrum from the sun. It shows you here. It's pretty crude. But again, I just pulled this off the internet. This is something that just shows you a little, see where the 280 is. Anything but below 280 is UVC. This is our visible spectrum. We can't see UV with our eyes. This is infrared. We can't see that either. That's what Scott's been talking about with the heating and all that, and that's definitely an awesome thought. Okay, so what do they use it for? It's right here. This is what they're doing. They can do. That's what they use this stuff for. They can use UVC for disinfecting things. UVC light. It says short wavelength ultraviolet UVC light to kill or inactive microorganisms by destroying, the acids and disrupting. Look what it says. DNA. So if it can do that to them, it can do that to us. Is what I'm trying to tell you. Okay, if it can get down to their DNA, it can get down to ours. All right, for the most part, in most cases. Okay, so keep that in mind. Have to. Now it says UVC light is weak at the Earth's surface as the ozone layer of the atmosphere blocks it. Okay? I mean, it's just crazy. It keeps saying that our atmosphere is protecting us from that, but yet we're still seeing it. Okay? Oops. So, they use it in, like I said, you can use UVC to purify water. I mean, that's what they use it for in air purifiers. It says it right here. This is a company selling these kinds of technology is what this is, what this article is. Okay? Again, self-disinfecting items. And they use it for baby bottles. Okay? It says they're wanting to put this stuff in like smartphones and tablets and keyboards and stuff like that, so it can sterilize them, so people don't get sick. So is that why they might be putting some of this out into the air? I don't know, guys. But I don't know what else to say about this. But I did want to bring that to you guys. Any ideas you guys have on why we're seeing UVC on the surface? Please put it in the comment section. I'm still researching this, and I'm not saying any of what I just said is 100% what it is. I'm just trying to say that, hey, we're getting UVC on the surface. Why is that? I'm asking this question. And these are the possibilities that I've come up with in my mind. And, because they tell you that none of it should be making it through our atmosphere. But yet we're still seeing UVC on the surface. So that means one of two things. Either it's coming from an artificial source, or it's coming from the sun, and our atmosphere has depleted so much that it's allowing that to get through. Okay? That's really the only two options, guys. So, anyway, guys, I'll keep you guys updated on the CME and stuff that happened, and I'll come back to you more with this as I get more research done. But anyway, still use sunscreen. Cover yourselves up. Don't stand in direct sunlight very long. Wear long sleeves. Wear a hat. All right, guys. I mean, that's good anyway. So, and you ladies out there that aren't afraid to do it, take an umbrella with you. It doesn't just protect you from rain. It can protect you from all that other junk, too. Okay? God bless. Yeshua saves, and you can drink this Kool-Aid.